In this example, we are going to see how to convert from a normalized form, from a sum of product or a product of sum, to a truth table. Converting from a canonical form, from a sum of mean terms, is straightforward, and as it is converting from the truth table to a sum of mean terms, because every mean term corresponds to just one row in the table, and vice versa. But we can also convert from a sum of product just by trying to find out what are in this case, what are the ones that correspond to every term in the table. So we will start by drawing the table here. So we'll have a table for the function. Here we have A, B, C, here we have Z, and all the possible values. 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So we'll complete the line like this, always. Make it a bit more straight here. Okay, now by looking at this expression, every term here tells some cases where the function is 1. We can say that z will be 1 if and only if any of these terms is 1. It means that AC complemented is 1, okay, or the next term is 1, A, B complemented, C is 1, and so on. But this term is 1. For this term to be 1, all the literals have to be 1, so it means that A must be 1 and C must be 0. This term is 1 when A is 1, B is 0 because it's complemented here, and C is 1. So these are the cases that we can find out in the table. So this function will be 1. We may continue and analyze all the terms like this. The next one will be, so z will be 1 in these cases, or when A is 0 and C is 1, or when B is 0 and C is 1 again. So in any of these cases we have that my function is 1. So I just have to find what lines correspond to these cases. This is A equal to 1, C equal to 0. I have it here. A equal to 1, C equal to 0, and also here. A equal to 1, C equal to 0. So I know the function is 1 in these cases because of this condition that comes from this term. Now the next term. The condition is that A is 1, B is 0, and C is 1. A is 1, B is 0, and C is 1. So in this case, my function is also 1 because of this term here. The third case is when A is 0 and C is 1. A is 0 and C is 1. This is this case and also this case. So in these two cases, my function is also 1. And the final case is when B is 0 and C is 1. It happened here. We already considered this, B0, C1. And here, B0 and C1. We already considered this case as well. So this is the cases where the function is 1. And in any other case, no term will be 1. So I'll have a sum of zeros and the function will be 0. So in any other case, my function will be 0. Okay? So the idea is sum of product means it's easy to find out in which cases the function is 1. With the product of sums, we can do something similar. In this case, it will be easier to find when the function is 0. So I will build my table again, A, B, C, Z. We write all the possible cases. Okay, and now I can say that Z will be 0 if and only if any of these terms is 0. I mean, or A plus B plus C is equal to 0, or etc. But this is 0 only when A is equal to 0, B is equal to 0, and C is equal to 0. Okay? Or this term is 0, but for this term to be 0, I need to have a 0 here. It means A should be 0, and I should have a 0 here. But to have these literals as a 0, I need B to be 1 because it's complemented. So I need A to be 0, B to be 1. Or the other possibility is that A is equal to 0 and C is equal to 0. Okay? In these three cases, the function will be 0. In any other case, the function will be 1, because in any other case, none of these terms will be 0. Okay? So this first case is when all variables are 0. Is this case here? Okay? So in this case, Z will be 0. These conditions correspond to A0 and B1 to this row, and A0 and B1 this row here as well. Okay, so in both these cases the function is 0 as well. And the last condition is A0 C0 is this case we already considered, and A0 C0 this case that we already considered as well. Okay, so there are no more cases. So in the rest of the cases, the function will be 1. Okay. So here we can convert from a normalized form to a truth table. We may obtain the canonical form, the product of max terms, as we did in the previous example, but it's not really necessary, okay, because it's not difficult to identify when the function will be 0 in this case, or when the function will be 1 in this case. Okay, that's all. Thank you.